Good morning, ladies and gentlemen. Today we are on page 17 of your student journal. And before we get started on our lesson, we're going to get our problem of the day done. So today we're going to be talking about multiplying decimals and just kind of reminding ourselves of some of the basic rules. So when I multiply decimals, I set it up as a regular multiplication problem and I kind of ignore the decimal. So I'm going to show you my first problem. My first problem is 5/10 times 42/100. And remember, I'm writing in green, which means I expect you to write it with me. So if we were ignoring the decimal in this problem, it would say 5 times 42. So if I was going to set that up, I would set it up with the 42, which is the larger number, on top and the 5 on the bottom. So notice the decimals don't line up. That's perfectly fine when we're multiplying decimals. So I'm going to set it up and I'm going to kind of ignore the decimal, and then I'm just going to multiply like regular. So I have 5 times 2 is 10. 5 times 4 is 20 plus 1 is 21. Now this is where it gets a little different. Now I'm going to deal with my decimal. So I'm going to do something called loops. I'm going to start here on the end and go a loop under the 2 and a loop under the 4, and then a loop from here under the 5. So I had 3 loops in the problem, which means in my answer I need to have 1, 2, 3 loops also. So my answer is actually 210 thousandths. Okay, let's try another one of those. If I had 4 tenths times 0 and 9 tenths. Okay, again, we're going to just ignore the decimals and we're going to set it up regular. So because 0, 9 is a longer number, I'm going to put it on top. And then my 4 tenths goes on the bottom. Now, I just had said I don't want to line up the decimal, and look what happened. Here it lined up. That's okay. As long as it lines up by itself and you didn't do it on purpose, it's okay. So we set up our problem, we lined up our digits, not really our decimal, and it just happened to line itself up. So now we're going to multiply like regular. I get 4 times 9 is 36, so I put my 6 and carry my 3. 4 times 0 is 0, plus 3 is 3. And now we have to do those loops. So 1 loop, 2 loops. So my problem has 2 loops. So my answer also must have 2 loops. So my answer is 36 hundredths. Okay, so ladies and gentlemen, here is your problem to try on your own. 9 times 0.7 or 0 and 7 tenths. And your teacher will be asking for the answer for that one. Okay, so now we're actually going to get started on today's lesson. So today's lesson, again, we're on page 17, and it says convert between mixed numbers and improper fractions. Okay, so our goal today is, today I will, and it's going to be exactly that title. Convert means to switch back and forth. That's what convert means, to change or to go back and forth. So I'm going to convert between mixed numbers, and we talked about mixed numbers yesterday. We said mixed numbers are when there's a whole number and a fraction. So between mixed numbers and improper fractions, and we will talk in a moment about what that means. So today I will convert between mixed numbers and improper fractions. Okay, so before we get started, let's look at our vocabulary. So our first one is, what is an improper fraction? It says a fraction representing a value that greater than 1 in which the numerator is greater than the denominator. So an improper fraction, two things that I see here is a value greater than 1. So if you have an improper fraction, that means it's worth more than 1. And it says also the numerator is greater than the denominator. So here's my numerator and my denominator. And notice the numerator is larger. When I taught 5th grade, I always told my students, like, it's improper because it's not set up the way it's supposed to. And we always talked about piggyback rides. Like, would you have a 7-year-old on a 5-year-old's back giving a piggyback ride? No, that's not the proper way. Or would you stack a box with a 7-pound box on top of a 5-pound box? No, you would always stack things with the littlest one on top and the larger one on the bottom. So that's why we call that improper. Now, it's worth more than 1 because these are equivalent. So let's look at the picture to kind of help us. I'm not going to worry too much about the number line picture. I think that the area model picture is a little more clear. So 1 2/5 means I have 1 whole. So this was our 1 whole. And then this was our 2/5. So I had it cut into 5, and I only have 2 of them. Well, what they did with my 1 whole is they also cut it into 5 pieces just to see how they are equivalent. So I have 1 whole and I have 2/5, which is here. And that's equal to 7/5 when I also cut up the 1 whole into slices. So now, in a picture form, that's great. Our goal today is to not use pictures and to actually use some math for it. So I'm going to not use necessarily the steps that they show you. I'm going to do just a little bit different steps of how to do this. Okay, so we're actually just going to jump in and get started. And again, I'm going to do a little bit different steps of how I would do these. Okay, so I am setting down my green pen and grabbing my red pen, which means you can put down your pencil and just watch for a moment. Okay, here is my first problem. My first problem is 1 3/4. So this is a mixed number. It's a whole number and a fraction, which is a mixed number. And I want to turn this into an improper fraction. Now, again, I could do a picture, but that's not going to be very efficient or very good use of our time. So what this looks like in a picture form, I'm going to show you, is it means I have 1 whole, and then I have 3/4. So I need to cut it into 4 pieces, and I have 3 of them. And I have this 1 whole. Well, if I also cut up the 1 whole, it's pretty clear now how many pieces do I have. I have 1, 2, 3, 4, 5, 6, 7 pieces, and they're each 1/4 big. Okay, again, that's a great method, but it's not very efficient. So let's look at a more efficient method that's going to give me the same answer. Okay, I have this 1 whole and it's cut into 4 pieces. So I'm going to say 4 times 1. So notice how I'm going. I'm going to go 4 times 1 is 4 plus the other 3 pieces I had. So I'm going to say 4 times 1 to give me these 4 pieces plus 3. So 4 times 1 is 4 plus the 3 other pieces gives me 7, and then my denominator stays the same. That's how I'm going to do it. So I do 4, I start here and I go times plus. So it's kind of just remembering this kind of pattern. 4 times 1 is 4 plus 3 is 7, and then your denominator stays the same. And that way I don't have to draw a picture each time. Okay, they don't really give me another one here, so I'm going to just do one up here on the side to show you another one of those. So if I had 2 6/10, what I would do is I would start here and say 10 times 2 is 20, plus 6 gives me 26 tenths. So I just kind of followed this pattern around. And that's how I would do it, which is a much more efficient way than drawing a picture each time. Okay, let's look at number 2, which now, notice they didn't give me a mixed number. Now they gave me an improper fraction. It's improper, which means the numerator is larger than the denominator, and I know this is worth more than 1. So again, I could draw a picture. The 3 tells me that my wholes have been cut into 3 pieces. That's what the denominator tells me, is I have something cut into 3 pieces. The numerator tells me I have 5 of them. So I have wholes that were cut into 3 pieces, and I have 5 pieces. So when I draw it, I see that I have 1 whole and 2/3. Okay, again, on a smaller improper fraction, it might not be too bad to draw it, but I don't really want to get in the habit of that. So I want to find a more efficient way. So a more efficient way is using something called in and out. Not the hamburger In-N-Out, although I love In-N-Out, but just the strategy of in and out. So I'm going to use division, and I'm going to put the 5 inside and the 3 outside. So 3 can fit into 5 one time. 1 times 3 is 3, and I'm left with 2. And 2 becomes my new numerator, and my denominator stays the same. Now, this might seem complicated, but this is a good strategy for when you have really large improper fractions to work with. Okay, so let's see another one of those. So I could draw a picture, but I'm going to instead use this in and out strategy. So my 2 goes out, my 4 goes in, and then I divide. 2 can fit into 4 2 times. 2 times 2 is 4, and I get 0. So it would be 2 and 0 over 2, which is just the same as 2. Okay, so we're going to try some of those together. Those are the strategies we're going to be using. So we're back on page 18, and I'm going to grab my green pen, which means you're going to grab your pencil and work with me. Okay, so our first problem together is an improper fraction, 2 and 5/6. Okay, so remember, I'm going to write larger because it's kind of squished there. For 2 and 5/6, I could draw a picture, or I could kind of remember the formula. I'm sorry, kind of the pattern. I'm going to start here, and I'm going to say 6 times 2 is 12, plus 5 equals 17/6. Because what I did is I took up these 2 wholes, and I cut them into 6 pieces, which gave me the 12 pieces. Plus I added the 5 pieces I had. So I have 17/6, but that's why. Because you took your 2 wholes and cut them up into 6 pieces each, and then you added the 5 extra pieces you had. Okay, so again, they only give us one of those, so let's do one over here so you can have an extra one. What if I had 5 and 2/3? Okay, so what am I going to do? Is we are going to say 3 times 5, which gives us 15, plus 2 gives us 17/3. And the reason is I had my 5 wholes and I cut them into 3 pieces each, so that gives me 15, plus I added the 2 little pieces I already had. Okay, let's look at number 2. Number 2 says 9 halves, or 9 over 2. Which this is an improper fraction. You'd never stack a 9-pound box on top of a 2-pound box. And I know this is worth more than 1. So what this means is something was cut into 2s, but I have 9 slices. So I obviously have more than 1. So this one we're going to use that in and out strategy. So 2 goes out, 9 goes in, and then let's divide. 2 can fit into 9 4 times. 4 times 2 is 8, and I have 1 left over. And that becomes my numerator, and my denominator stays the same. So it's 4 1/2. So 9 halves is the same as 4 1/2. Okay, let's try one more. So we have 10 over 5, or 10/5. So we're going to do in and out. So my 5 goes out, my 10 goes in, and 5 can go into 10 twice. 2 times 5 is 10, and I get 0. So 0 is my numerator, and my denominator stays the same, which is 2 0/5, which a better answer would just be 2. Okay, so ladies and gentlemen, you are going to be trying page 19, 20, and 21 on your own. Have a nice afternoon.